Welcome to RSET Online. Today I am going to take a session on normalization of principles of database management system for CS and IT students. So as we discussed in the last class, functional dependency X implies Y can be represented like this. That means X, the attribute X can uniquely determine the values of Y. Consider an example of table employee. The attributes are employee number, employee name, salary, and the values are 1, 2, 3 for employee number attribute, and for employee name Ram, John, Sam, and their salary is given as 2000, 3000, 4000, and the key attribute is employee number. So first of all, the functional dependencies given are employee number implies employee name, employee number implies salary. So if we get the value of employee number, we can obviously retrieve the values of employee name, salary. Again, if we get the value 2, the corresponding values also can be retrieved. So X implies Y indicates for every value of X, there will be a unique Y value. That is the concept of functional dependency. Next is inference rules. Inference rules are IR1 to IR6. IR5 and IR6. IR1 is reflexive rule. That is X implies Y. IR2 is it says that X is a superset of Y, then X implies Y. IR2 is augmentation rule. That is X implies Y indicates XZ implies YZ. IR3 is transitive rule. X implies Y, comma, Y implies Z is there. This indicates X implies Z. IR4 is decomposition. Rule. X implies YZ that indicates X implies Y. Next is union rule. X implies Y, comma, X implies Z indicates X implies YZ. IR6 is pseudo transitive rule. X implies Y, WY implies Z indicates WX implies Z. So the first IR1, IR2, IR3, that is the first inference rules, first three inference rule is known as Armstrong axiom. Next, using this inference rule, we have to find out the closure of an attribute. Next is closure. So the closure of an attribute is represented by X plus. We will start from an example. Find out the closure of SSN, P number, SSN, P number from the given schema of employee table, and the attributes are SSN, E name, P number, P location, hours. The given functional dependencies are SSN implies E name, P number implies P name, P location, SSN, P number implies hours. So first of all, to find out the closure of SSN, SSN plus equal to, that is SSN closure is equal to, include SSN first, then we have a functional dependency SSN implies E name. So from SSN, E name is the attribute from the given functional dependency. So add E name. Okay, this is the closure of SSN. Next question is closure of P number. So P number plus equal to, closure of P number is equal to include P number, then from the P number, P name and P location is there, add them also, P name, P location. Then last is to find out the closure of SSN P number. So the closure of SSN P number is equal to add the first SSN. From the SSN we will get E name from this functional dependency. Add the P number. From the P number we will get the function dependencies. From the function dependency we will get P name and P location. Then SSN and P number together determines hours. So from this identified closures, the closure of SSN P number containing all the attributes of the given schema. So from this closure, we are moving to the topic key attributes and non-key attributes. So in the table employee, the attributes are SSN, E name, P number, P name, P location, hours. So first of all, in the SSN closure, the attributes are SSN and E name. So here only two attributes are there in the SSN closure. Next, take the example of P number attribute. The P number attribute contains, the P number attribute closure contains P number, P name, P location. Here only three attributes. And in the SSN P number closure, we have SSN, E name, P number, P name, P location, hours. That means all the attributes of the employee table are included in the closure of SSN P number. So the key attributes of this schema are SSN P number, and the non-key attributes are list of all the attributes minus key attributes. That means from the given set of attributes, remove the key attributes. That is E name, P name, P location, comma hours. So these are the key attributes and non-key attribute. This concept of key attribute and non-key attribute is very important for doing the normalization process. So next is normalization. Before going to the normalization, we will do one more examples on finding key attributes and non-key attributes. Given a relation R, A, B, C, D, E and F with functional dependencies, A implies B, B implies D, D implies EF, F implies E. And we have to find out the closure of D and the closure of EF. The D closure is equal to the D, the same attribute, comma, from the D we will get E and F, comma, to add the attribute E and F from this functional dependency. From the F we will get A, from the attribute A we will get D. So the closure is A, B, D, E and F. Next find out the closure of EF. The closure of EF is equal to add the attributes E and F. From the E attribute F we will get A. From the attribute A we will get B. From the attribute B we will get D. So the closure of EF is equal to A, B, D, E and F. So coming to the normalization, what is the purpose of normalization? Normalization reduces the replication in table and to remove anomalies. The normalization actually is done by checking with the normal form test, and if a particular normal form is not satisfied, we will decompose into smaller schemas, and this process will be continued until we will get a normal form that is okay with the given schema. So when the required normal form, until the required normal form is found, we will do the normal form test and decomposition. So the normalization is done by step by step. For that, different normal forms are there. The first one is 1NF, that is the first normal form. Second one is 2NF, that is second normal form. Third one is 3NF, third normal form. We have other normal form beyond this, but now I am discussing regarding only with first normal form, second normal form and third normal form. So actually this is a formal framework for analyzing relation schemas based on their keys and the functional dependencies among other attributes. A series of normal form tests can be carried out on individual relation schemas so that the relational database can be normalized to any desired degree. So, given a table of department and the attributes are D name, D number, D manager SSN, D location. And the table is given as department, D name, D number, D manager SSN, D location. First of all, D name is research, D number 5. Next is admission, D number 4. D manager is 1, 2, 3, 4, 5, 6. D location is SAIND. Here the locations are US. So the first normal form says the attribute should be atomic in nature. In this table, the research department having the D location SA and IND, that is multiple locations are there, but this attribute D location corresponding to the department number 5 is not atomic. Atomic means it should be indivisible. Atomic means it should be indivisible. So, in order to make this table in first normal form, we'll add the department table. Into the department table we will add one more record, that is, first of all the attribute is D name, D number, D manager SSN, D location. Divide this composite attribute into, or this non-atomic attribute into 2 rows, that is the research department having department number 5, 1, 2, 3 SA, and admission department having department number 4, manager assistant 4, 5, 6 US. And we will add one more research with D number 5, manager SSN123 with IND. So this actually D number was the key attribute. Here having duplication, so we make a composite key attribute composed of D number and D location. So this is a way how we are making this table into first normal form. The department table was not in first normal form because of this non-atomic attribute. So make this non-atomic attribute into atomic attribute by splitting into 2 rows and making the key as a composite primary key composed of D number and D location. So next is second normal form. Second normal form 2NF. It says if a table is in second normal form, it should be in first normal form, plus there is no partial dependency from the key attribute. See the above the example discussed for the closure, the attribute, the employee table is given, and the attributes are SSN, e-name, P number, P location, P name, P location, hours. So from the given closure example, the key attributes are SSN, P number, because from the SSN P number closure we will get all the attributes. So the key attributes are SSN and P number. Non-key attributes are all the attributes minus this key attributes, that is all other attributes other than key attributes. E-name, P-name, P-location, hours. Here the functional dependencies given are SSN implies e-name, P number implies P name, SSN P number implies hours, here one more attribute, P number implies P name, comma, P location. See, SSN P number is a key attribute which directly functional dependency determines, like SSN P number determines hours. Here this part of this composite primary key is determining another attribute. That is, there is a functional dependency from this part of this composite primary key to a non-key attribute. Here SSN is a key attribute, P number is a key attribute. From the key attribute there is a functional dependency to other non-key attribute. So this is called partial dependency. That is, SSN P number implies hours, SSN only can determine E name. that is a partial dependency. Here also one more partial dependency is here, P number implies P name, P location. So second normal form says already the table is in the first normal form and no partial dependency. So in this table, to eliminate this partial dependency, we will decompose the table into different tables. First of all, SSN E name as a first table, we will give it as R1. So this is actually creating a partial dependency. Another partial dependency is R2 will create one more table. P number implies